Graph f of x equals 1.5 raised to the negative x. State whether the graph of f illustrates exponential growth, exponential decay, or logarithmic growth. So I've set up a table here, x and 1.5 raised to the negative x. So if we substitute negative 3 for x, negative of negative 3 is positive 3, so this would be 1.5 cubed. Now, just to give an idea, without using a calculator, we know 1 cubed is 1 and 2 cubed would be 8. So this value of 1.5 is obviously more than 1, but going to be a little bit less than 8. For negative 1, it would become a negative of negative 1, which is a positive 1, and so it would be 1.5. When we substitute 0 in for x, we get 1. When we substitute in 1, we get 1.5 raised to the negative 1, which means if I think of 1.5, that's really 3/2, 1.5, but then I want the reciprocal of it. In other words, 2/3. And for 3, we would have 1.5 raised to the negative 3. But again, if we think of 1.5 as 3/2 raised to the negative 3, that would really be 2/3 raised to the power of 3. And of course, this would be 8 over 27. So, having said that, we could go back up to the 1.5 and do the same thing. 1.5 would be 3/2 cubed, and that would give me 27 over 8. That gives us a better idea. 27 over 8, 8 goes in there 3 times, and there would be a remainder of 3, so it's 3 3/8. So now, when we go to graph this, we know that it's negative 3, and it goes up to about 3, and 3/8. So let's put it there. We know that at negative 1, we have 1.5. Negative 1, 1.5. At 0, we have 1. At 1, we have 2/3. And at 3, we're all the way down to 8/27, which would be about right there. So we can see that what our graph is doing is coming down like this and approaching the x-axis over here. Here it's going up to infinity. So this is the graph f of x equals 1.5 raised to the negative x. This is an example of exponential decay.